Hi folks, welcome to the fourth episode of On Time with Dr. and Serge. As you can see, we have been talking about logistics and tech and bringing you some complex topics, right? For example, we talked about in the first episode how to get the ROI of your technology implementation. In the third episode, we talked about why most of the companies cannot replace Excel. And I hope you like that video. If not, go and check the link in it will be somewhere, right? But today we're going to talk about when robotics will take over humans in our logistics section, because we have been talking this of robotics over a decade. I know I go to a lot of conferences, there's a lot of companies, they're talking about warehouse automation, etc. But again, in my view, as a logistics professional or supply chain professional, adoption is pretty slow.
On Time with Dr. and Serge, Logtech podcast.
So now we have here Mr. Serge, who has been a CEO and founder of our company, who's actually working with warehouse automation, right?
Right.
So,
yeah. Hi, Doc. Nice to meet you.
How you doing? You're right these days?
I'm good. How
Good,
about
man.
you?
Very good, very good. So we survived the reign of the Dubai, and I think logistics was gone pear-shaped. And a lot of people did not go to the warehouse because they are people. But I'm pretty sure robotics don't worry about that, and they are in the warehouse. So there's a lot of
Under the water.
Under the water. But there's good reason for adoption of the robots in warehouse, and we're going to talk in length, good examples and challenges. But why you think it's been decade we are talking about it, and it's not happening?
So it's a hot topic.
Definitely.
Was and probably still very hot topic.
Yeah, it will be.
When they took my job,
Yeah.
those robots.
Yeah.
But before I give my answer, I want to ask you,
Okay.
what's your take on that? Why do you think there are
Right.
not many robots?
Right. I'm gonna give you an example, and I can give example because I was in 2000 and I think it was 8. I was working for Eaton. Right. There was
Where?
a big Eaton American corporation. Right. If you go on LinkedIn and you can check, I was I think a materials manager, demand planner at that point in time, and there was an announcement that Eaton Electric or Eaton bought Cooper Industries for. It was one of the biggest acquisitions. It was like, I don't know, 3 or 5 billion. Don't remember the number. It was in billions. It was the biggest acquisition they did. So one thing which was super excited about Eaton was or Cooper was, they have a warehouse in Meckenheim known as MDC, Meckenheim Distribution Center, which was automated. Big deal. And they invest at that point in time, I'm talking 2008, right? About, if I remember correctly, anything between 10 to $12 million to have the automated robotics picking. I'm talking picking only. Okay, I super excited, and because I was in the top talent and all that, they extend me a invitation. I went to Germany for the first time. I'm getting a very nice protocol. I arrived in Meckenheim warehouse. It was in the middle of nowhere, right? Massive warehouse, middle of nowhere. And when I went in, and I was like, oh, I was impressed, right? There was big, like from the bottom to really, big, tall shelves, and you can see in between robotics arms going in and picking. So, but then there was on a very small area. So I heard it was tens and millions of dollars being invested, but literally is only 1/8 of the warehouse actually doing the robotic job, but the remaining, let's call it 7/8, is doing the normal warehouse. There's normal shelves, there's normal picking and packing, there's normal things, people moving around in pallets to do pick, pack, and ship, or basically inbound, unpack, and put into pallets. Then my first question was, why is that, as an immature? Then said, okay, the thing is, we have to, because Eaton Electric used to do circuits, fuses. So robots at that point in time can only pick and pack small stuff, because the thing is, I'm going to use this, for example. I'm not sure I'm allowed, but I'm going to use this. So for example, this is basically a container. So what they used to do, they could go in, they pick the fuse or the circuit, put into here, they pick 4 or 5 to do from the shelf up and down very fast, and then they have the order picked. And it has to go in a trolley. So to control the quality, it's by weight. So if the robot has not picked correctly, so they say the weight is not there because the weight has to be filled in to do that. Now, so the guy who was explaining me, so to see this operation, it's literally a 5-minute job, and you got bored after that. But the guy explained, to make this robot work, right? To do what we want, it's weeks and months of preparation. Natural question, why? He said, we have to decide what product we're going to put in. It has to have a size. It has to have a barcode. We have to put spec. We have to put their weight. We have to put their size. We have to put the packing material. So to do that, we need specialized people to do this. So first answer of your question is initial capital involved to install, right? Then after installation, to make it work for you, which requires months and months of preparation. How many business in the world right now, they have their product data, which is the weight, the specification, the size, everything involved related to the movement of the product in the ARP or WMS system. I do a lot of consultancy, and you'll be surprised, less than 1% have it, right? Because easy to pick the box, put it in. I work for Bridgestone. Very, very, very difficult to do that. I mean, you could think for a tire, moving of tire, you should have it, but they don't used to have it as much as now. First issue. The second issue, I think we have been talking before this episode, as you rightly mentioned, is maintaining of those robots. It's very, very difficult. It's costly. If human get ill, they have a bad back, right? Okay, you can have 2 weeks sick leave off, go and rest, come back. Okay, we're going to help you with proper ergonomics that you have to go straight away down, straight away up, put it in. Don't go above your height, don't go below. Ergonomics, right? I've done all the warehouse health and safety, management of a lot of warehouses, so I know what's involved, right? You can design warehouse for your people to be safe and move better. Robots, if they have a back pain, if there's such a thing, right? Nobody can fix it. You have to call the specialized engineer from wherever they are to fly in, pay them. It's going to take time, and he's going to do whatever diagnostics to figure out what's wrong, and your robot is down, right? It's costly. The running cost is super expensive. In my view, there are the two reasons. What do you think?
You're kind of correct.
Kind of correct? I'm correct.
Yes.
Kind of correct.
Rough estimates is that probably just 1% of jobs are now occupied by robots. And to get to 25, we will need to wait maybe a decade or two. Just do that. And the limiting factor is engineers. You have just few engineers, young people that can do all those specific tasks to just manufacture those robots, to design and test all those robots.
Because all the young people are on TikTok making.
Yeah. Just correct. Yeah. So it's not the capital itself, although knowledgeable stuff is a capital. Yeah, in your country, if you have plenty of knowledgeable people, that's a capital. But imagine how much capital is frozen in 30-year US bonds. So with zero interest, right? So if your robot stuff needs plenty of capital, I don't know, trillion USD, but you can be sure that it will be more than zero interest in 30-year time. Of course, you will get that money. But the limiting factor is not the capital, that type of capital, not money, but engineers, right? And until robots will be designing their own bodies themselves, you will not solve that. So the key to solving that is robots designing their own bodies.
I want to challenge it.
That in a decade, that will be solved, and then designing robots will be cheaper. Another thing with the maintenance,
can I challenge you there?
Oh, sure, of course. Yeah.
Your statement of it will take decade for robots to design robots. So basically, Terminator 2 to design Terminator 1 will take 10 years.
Yeah.
Right. I would have agreed before November 2022. Right. I would have agreed to that. But post November 2022, I don't agree. I don't want to mention why I'm saying November 22. Everybody should know that. Because AI is there right now, which is basically, I was watching a video recently, and they said autonomous vehicles are actually the future of technology. Like big statement, a future of technology. Why? Because it utilizes basically the three technologies which is emerging, which are AI, right? Robotics and energy storage. Right? Very good example actually. But then the speaker said both of them are getting very independent. AI is managing AI, right? Robotics can make robots. And
accelerating
accelerating
themselves.
fast, right?
Yeah.
So
Right.
now the challenge I'm saying this, if the AI can teach robots to make robots faster, why is it going to take decades? I think there's so much money in startups, right? Why compete?
Oh,
People got billions, right? So if somebody wants to do a startup right now, is to do a startup.
Design is not the whole thing.
Okay.
A question for you. You're a supply chain guy.
Yeah. I am
How much
probably-
time it takes from a clay to become aluminum to become some spare part that will go into Boeing airplane?
That's a geographic
How long?
question. That's a geographic
Yeah,
question.
yeah, but how long?
Or geology, to be very precise, not geography. Apologies. Geology.
I dug up the clay.
I don't know. For me, what I know, it takes hundreds of thousands of years to coal to become diamond. That's what I know.
No. I dug up the clay.
Yeah.
How long it will take for that clay
okay.
to become
Right.
a
Aluminum.
spare part
Okay.
inside the Airbus?
I think I can answer that question with some precision because there's a company in UAE which is Guinea, right? What they do aluminum ore. So they really go to the mine, they take the aluminum ore out. It takes 2 to 3 months to clean it enough to send it to the factory, right? So the lead time is three to 4 months, and the aluminum factory will take another 1 to 2 months. So it's 6 months average to take the, let's call it from the mining.
Just to go to aluminum.
That's correct.
Right.
That's correct.
And then another year and a half to become a spare part for Boeing.
Correct.
So 2 years of that. And
point.
that is a well-designed, very efficient process.
I wouldn't call it efficient. But
No.
well-designed, yeah.
I mean, it's all, everybody knew each other. So it's like
It's
very,
not well designed. It is not
Anyway.
well designed. It's the current design. It's not well
okay,
designed.
current design. Yeah. So there are longer routes. And if you try to redesign all that, it will take time. See?
Yeah.
Going from, so that's why.
But it can't
So the
go- is
robot
it-
will design itself, but then you won't be able to manufacture spare parts. So the robot will have to design the factory. Then he will have to design the how to excavate the raw materials and until you build the whole that whole thing, yeah, it will not work. Even with those are so-called subtractive technologies, meaning you have a bunch of metal and you trying to remove material, subtract material to get a thing. Yeah, there are additive technologies. Additive, like
Additive.
3D printers.
Yeah.
When you got this dust or something, you just heat it up and then you got that. Yeah, but anyway, you have to design that whole path from raw material to the finished. That's why it will take time. Yeah, again. But the second part with the fixing and repair and all that, if you have an automated conveyor line, the main problem with that is that you have to replace all those bearings all the time,
Yeah.
right? And you spend on that. Same with all the robots that are navigating your warehouse. They break, you have to fix it. You need engineers, salaries, pension funds, all that to cover just to fix your robots, to maintain. And those costs just add up, and probably in some fancy startup, nobody will pay attention to that. But if you're a supply chain company, you ruthlessly cut all the inefficiencies. You find cheaper ways of doing things. And if you compare some immigrant with this thing that you don't have to just spend capital, but then repair and pay to the engineer, then it's become ineffective. Yeah. So the second problem is like is very interesting one. Robots building other robots is okay. Robots repairing other robots is a Skynet. You get it,
Yes.
right? because they will be building and repairing and all. So probably you shouldn't do that. Maybe not
For the human
full, yeah, not go
Elon Musk
full
is against
circle,
it,
full
right?
Monty with that.
So just keeping the time check of the episode here. So we covered that topic at length. Good views, I think, all around for both of us. Now there's another challenge in the automation adoption of robotics in the warehousing, which is the designing part. Let me give you a good example to explain the challenge, right? So recently come across a content where it was said that which company right now is a benchmark for supply chain logistics, which is Amazon, right? Amazon has really become the excellence of how the logistics is done. A lot of people trying to do it, they can't. Amazon has their warehouse and logistics operations, 2/3 is automated. They design pods, basically this product movement, shelving, and everything.
in
right?
terms of operations. Yeah.
Right? But still, they deploy hundreds of thousands of people. If I remember correctly, it's 98,000 warehouse workers, right? And people do permanent, like
Yeah, and then probably
temporary.
300,000
temporary workers.
temporary.
And then people complain about their conditions of the warehousing, despite all this automation. I think the real challenge here is not the operation itself, robotics or not, is designing of the warehouse operation which run using the high level of automation. So basically having a robot, let's assume a day we have a robot who can do robots, right? But somebody has to design the warehouse, right?
Yeah, but that's a 3-step thing. So
Please explain.
So NVIDIA is a big player on that with their platform, Isaac, that does exactly that thing. So they design this virtual environment that doesn't just looks great, all these concrete floors, racks, stories 11 stories high, but also the physics associated with that,
materials and everything.
all the materials, all the like real construction materials, strength of materials, physics of that, and then all the optics of that. Like what the robot will see, what the robot will sense, what the robot will feel.
It's more than digital twin. Or
So
is it digital
now you
twin?
can design this virtual version of a robot and then run all the physics tests, all the routes. So you will test both the physical part of the robot, engines, batteries, everything, You will also test how you laid out your warehouse optimally or not, what are the obstacles, all the other things. So the full tests, right? And then the software that runs on that robot, it can't tell whether it's a real warehouse or it's a virtual one. See, it sees same thing, it senses same thing. So it will perform all those tasks. Go pick that thing, move it here, transfers, all that, but at much faster rate, like 1,000 times faster than in real life. So, old ways of doing things. You design your robots, you're trying to make it, assemble, then you try to find a warehouse for testing, you build your racks, you put robots there, and then you try to run, you learn what are the mistakes, you cut something from that robot, you update the firmware, and it's so long, New ways of doing things. You design your robot using the commercially available bearings, engines, everything that is already in that NVIDIA Isaac. You just get those.
It's like inventory sitting there.
It's like, the whole inventory of whatever you can buy in China and whatever. You assemble your robot in virtual space, and then run all those tests on millions, gazillions of different warehouse layouts, warehouse jobs, and robot, you test that. And then the second step. So testing now can be done in a week, right? Not in a year, like an old way. Now, second step, this robot designing robot stuff. You have not an engineer who learns from the mistakes, but another AI that will tweak with the robot design, run tests again. tweak more, run tests, tweak more, run tests. And as long as that thing will be hundreds, thousands faster than doing that in real life, you will really progress with both design and all these smart things that robot will do.
Okay.
That's my answer.
No, but you said there are 3 steps. You explained 2. The first step is the simulation.
Okay, then you just make the robot.
Then you make the okay.
Yeah.
Simulation first using the NVIDIA Isaac Slim, right?
Yeah.
I think we can give a link on the video below so you guys can check it out, right? The second would be the robots, designing robots, and the third is, one more time,
Making that robot. Yeah.
Right. And to do that, we need billions of investment, right? Even
that's why NVIDIA stocks is
that's why NVIDIA stocks is so high.
Yeah.
Right? There's this kind of stuff which people don't do, right?
Yeah.
And
but think of it. Why the stock is high? It's a projection. So now they have this ratio of revenue for stock, like 400 years.
Wow.
Only in 400 years, they will repay with dividends on the current revenue. So whenever is paying this much, expects tenfold, probably 100-fold increase in revenues of NVIDIA. And it's already hundreds of billions, right?
And that's why.
So, yeah.
Sam Altman.
Sam Altman.
Yeah, he's trying to raise billions.
The CEO of
he's trying
7 trillion.
Yeah, so he's trying to raise several trillion to compete with NVIDIA, which I don't think he's going to get it, but he might be lucky.
But anyway, you can, there's not many industries that have this much value that should be disrupted by trillions in revenue, right? Probably supply chain will be part of that. I don't know. Do you know what's the value of supply chain worldwide?
No, I don't know the value of supply chain worldwide. What I know is the current cap of supply chain software market projected for 2025 is $76 billion. With the CAGR of about 7.1 to 7.7% growth, which I think is a massive market if anybody wants to be in supply chain software market right now.
So assuming that logistics companies spend maybe 5 to 10% max on software, those are the revenues, $500 billion probably, right? Okay, yeah.
So that is that, right? So in essence, if I just take the conversation to the more on a conclusion side, so despite the demand and desire of having a robotics or automated warehouse, there is the possibility of adoption is very minimal. If you think there is 100,000 warehouse globally, right? I think out of the 100,000 warehouse, I think there's less than 1% warehouse is capable of adopting the automation, robotics, what basically Amazon
absolutely
does,
true.
Right. What Amazon done is exceptional, right? And therefore, a lot of people have tried, and Noon has tried, everybody has tried. So, and that's why they can't compete with the prime service levels, right? Because they can't compete on the automation part, right?
Yeah, right. So hard truth, yes, you have to be capable. But take that example with ChatGPT. They had 100 million users in less than a year. So if you have technology at that level of adoption, like so accessible,
right,
that you don't need a math degree or engineering degree to use it, then then things will change.
No, but I can also want to quote a slightly not so successful example of high automation, which is Alibaba. I do not have all the facts with me like I have for Amazon, because if you go to my blog at SCMDOJO, we recently published a very detailed blog on why Amazon is a 30 billion opportunity when they ship out, right? So not mentioning selling the company, but mentioning the blog here. Alibaba has spent billions also in automation, but they are not as successful. What do you think? Why do you know? Do you know
engineers again? It's all down to engineers. So probably most of the smarter Chinese are in US,
right?
Yeah, working in Amazon.
That's a bit harsh.
Yeah, I think that's a problem.
That's a problem.
So it's now that's a limiting factor,
right?
And it will continue for a decade at least. Yeah, right. Yeah.
So but I want to bring it down. We're talking really billions and trillions and automation AI. I want to bring the discussion to a bit more practical. Let's call it lower level. Your software company, I know, Cleverance, does a good job in various automation of the small task. Give us some quick wins for the audience, because I always believe, and even I was talking to my team today, whenever I ask them anything, they talk about, oh, we're going to do dashboard and micro and 20 this and automate this, and we were going to bring all the analytics of YouTube and GA into one place. I said, no, start small. Right?
Yeah.
So what baby steps you would recommend for people to start a warehouse automation, then go for like blue ocean like Amazon?
Cleverance automate warehouse business processes.
All right.
So it's still Excel there, probably, yeah, but the data is collected for Excel automatically, and it will be uploaded into backend ERP or create other steps, other workflows automatically. So that's what Cleverance does. So if you don't use Cleverance, don't use automation, you will have to go do your job, then come back, type it in ERP, or bring sheets, and then next day you will have reports, how much you have on stock, where everything is located, have we delivered that or not, yeah? With Cleverance, you just, by doing what you do, delivering, collecting, you will immediately have all that reflected in the data, in ERP, in the database. So that's what we do. It's a simple thing. You can start it from day one. And that's actually resembles I'm remembering our episode about Excel, that you have to automate broader things. So guys, if you haven't seen that, go and check the link for the third episode. And what that thing does, it just makes your enterprise run faster. All the clocks starts ticking faster. Now you don't have to wait for the next day to see what was delivered, what's on stock. That shrinkage, it's not real. It's just in your ERP or in your Excel. But now you can see, oh, I can get rid of that stock, or I can get purchases, payments quicker. It's not just proof of delivery, but all the documents are created automatically, sent, and the payments. Yeah, so just cutting that extra day to payments, you get more money. Yeah, right. So ticking faster. It's again an episode on how to calculate ROI. Go check this one, like a first episode. It just by doing that, you fix all those other two things in three
velocity,
V's. Yeah. Increase velocity. Now you have better visibility and better variance.
Right.
Now, variance doesn't affect you as much as before.
Right. So these parts you can automate, right, based on technology you have built, right, and then they can improve the velocity, visibility, and reduce variation. Therefore, we talked about in our episode 2 in detail the benefit of that. Therefore, save money, because essentially there has to be some kind of ROI. Then you invest money that has to be recovered in X amount of time. And I think we talked about in episode 1, as you mentioned, that
and then
how you
an
do that.
easy patch.
Easy patch.
So like Cleverance is not a separate software completely.
Easy patch.
It's just a patch for what you already have. So it's integrated in your processes, your IT infrastructure, your ERP. Yeah.
Cool. So my conclusion of this episode is following: that you start small with the examples you've given just now, right? And take it to the level where you can improve velocity, visibility, and reduce variation. So going for euphoria like Amazon is not impossible. It's very possible if you got the money, you got the engineers, you got a desire to do it. Also, you have a scale to do it. If you don't have a scale, the ROI will not be there, right? So it's not everybody's game, because on one hand, people desire about automation and robotics, and trust me, I've seen with my eyes in 2008 happening. So still, a lot of companies who desire to do it couldn't do it because they just don't have volumes, right? So you need to have a volume to do it. So that's my conclusion. What's yours?
My conclusion will be that there will be few niches, very specialized, left after all that. Big companies will eat our lunch. So probably everybody should be concerned on learning more what you can do with what you already have. Because you cannot postpone that any longer. Yeah, in 5 years, the market will be very different. And if you don't start today, educating yourself on all those things, trying to do something about it, taking actions, maybe mistakes, but again, starting it now, not tomorrow, now, right? Then probably you will survive that disruption.
Before we go, so warehouse will be, so robots will be competing with the people. They already are. So I ask you the question, why are robots get promoted? What's your answer?
Most of the Western companies, they don't pay for repairing people.
Yeah.
Unless they're really damaged. Yeah? But you do repair robots, right? I think the question is mostly political. Okay, like we're in UAE. In UAE, you can have as many employees as you like without being afraid of they replacing you as a general manager. Yeah. In Western countries, that's a very stark possibility that just they will form a union and then replace all the management. So it's kind of political. It's partly political. It's partly because by doing robots, you can separate yourself from the old world that is using human labor. You can introduce new regulation, not just on green stuff, but your employees will have to work 3 hours a week. How about that? And then if you have robots, you compete. If you don't, you cannot export your stuff into Europe or US. Yeah. So it's partly anything. So as any complex issue, it covers a whole bunch of topics, and on the conversion of a whole bunch of interests, it involves demographics, it involves how the capital moves, the cost of this borrowed money, it involves the education, all of that. It just leads to this single logical thing for a West world to do, is replace unskilled labor with robotics. Maybe in 25 years, but that's where the whole thing started.
My question was, why robot get promoted over a human? And you give a very serious and logical answer. If you would have asked me this question, I would have said because robot was exceptionally outstanding in his job. Simple, literally. Right. Okay. With that, love this episode. Right. Fantastic content.
Yeah, me too.
See you next time.
On time.
On time with Dr. and Serge. Logtech Podcast.